How you doing? I'm Joshua Diesner with JBD Builders. This is the JBD journal entry number one. We're going to talk about a water damage on a project we did when we were replacing all new windows and siding. Hope you stay tuned and hope you learn something. All right. So the project, as it started off to be, was a complete renovation or a complete window, all new windows, all new siding. We did this particular job. We did James Hardy plank, and what we found. Look, the existing home. Here, I'm gonna start you here. This is a good um, it's a good place to start. So the existing home had clapboard, right? Wood clapboard, super common in 1950s, 1960s construction, maybe a little bit earlier. Really, what it is just beveled plank siding, right? They nail it up top here, and then the next course covers it, right? So then the nails for this course are there, so on and so forth. They work their way up. This is exactly how James Hardy is installed today. Um, the issue with these, well, obviously just the age in general got to them after a while, but what what you see, what had happened over the years is the way the system is designed is it absorbs water and then it dries out. It absorbs water, then dries out, and that creates cupping, right? So the board started cupping over the course of time, and what somebody over probably in the 90s, late 80s, 90s, they decided that the answer was to go around and put nails in all of them, right? So if you want a board that's like this to be flat, you just put a nail here. Makes total sense to someone who doesn't understand the way the system is designed. And then they filled the nail hole with some putty and then painted over everything. Fantastic. What that resulted in is the board now holds water and the water can't get out. So it just starts to rot. And where that leads is you see the paint peel, right? And this is a pretty bad example. This turned out to be one of the worst examples I've seen as far as rot goes. But the, this is all indicative of it. So I mean, if you've seen any of this, it's time to start talking about some new siding in the short term. This is paint peeling off, right? I mean, you can touch. You'll see a few of them here, right? So, like right here, you could touch this and it just becomes dust in your hands. Right? Again, this is a pretty severe example, but these are all. This is the kind of stuff that we're talking about. Um, all right. So again, in this particular case, the the inside corner here is a mess. It's two walls come together and the deck's underneath it. It's inevitably going to hold water here. Um, and then you see this aluminum flashing. I mean, this is good practice in building. It's something that we do. You know, they've done since they've been building decks, as far as I'm aware. What it does is it actually sits on the sheathing, or the vapor barrier really is supposed to be there, but and then it sits below the deck. The deck is bolted on like this, and any water that comes here has no choice but to go down below the deck, right? That's the way it's designed. Now, in this particular case, this dimension is 6 inches, maybe. So any snow that's gathers above 6 inches, um, yeah, I mean it's not going to really do anything against that. The other the other thing, this particular flashing was, and you're going to see this a little bit better here. This particular flashing was fighting is the deck itself is actually back pitched towards the house, which means any water there is going to go. Now, this is a similar condition to the siding, right? So these are all supposed to be gaps, right? You see the individual planks in the boards here. These are supposed to be gaps between the boards to allow water and snow and whatever to go through to the bottom of the deck so that they don't sit on top of the deck. Now, pressure treated deck boards, right? Pretty standard operating again for the time period. They hold water. When it gets wet, they hold water. They absorb it, they dry it, but they're pressure treated so they don't rot as easily. It is not true that pressure treated wood does not rot. Pressure treated wood will rot, just rots at a much slower pace. But these boards were not actually rotted, they were just painted over, and again, it trapped in that moisture. And so when they absorb the moisture, it has nowhere to go, and the deck board expands. Now, what that does is these gaps that were once probably a quarter of an inch, right, eighth of an inch, 3/16, somewhere in that range, are now little to nothing. And so what that does is it traps water. Now it becomes like a floor. So the water has nowhere to go. It pools, it ponds, it freezes, it thaws, it rots the wood. So all these conditions are coming together to make a really disastrous outcome for this this deck and the structure of this house. So you see, as I'm going through here, we're just putting our fingers through boards. Like this is the box beam or the rim joist, right? Just put our finger right through it. This is the structure. Not only helps support the wall and the house, but it also is the structure that the deck hangs off the house. So the deck ledger board is nailed and bolted into this structure, and is actually what ties the deck to the house. If that were to fail, the deck has a potential to pull away from the house. It's been seen before. So as we're going through, the more we took off, the more rot we found. Again, this is a pretty severe case, but this is the clapboard failing and rotting from behind it, from the outside, from the inside out rather. This is just, again, put your finger right through it. So this is also where 3 roofs join, and there was a 1 4-inch gutter here. Had zero chance of taking all that water and putting it anywhere close to where it needed to go. The volume of water was just so intense. And so what's happening is it's all pouring over the side of the gutter, and it's all getting in here on top of the door. This is where it particularly was bad. Yes, I would like to stay on the call. Thank you. Okay. So we had to rip all this stuff out. All new structure, new door, new studs. We built a wall. We rebuilt the wall from the outside. Tried our best not to disturb too much sheetrock. Let's see, it's all. So what we found out is we need to actually replace the rim joist, which is the structure I was talking about before. So as explained, the deck is actually tied to the rim joist. So in order to take that out, we had to re-support the deck. We actually built a temporary wall below the deck to pick up the structure and the weight so that we could detach it from the house and not have it fall. It's good. It's a good thing to do. So this is what you're looking at, the temporary wall, support the deck. You see it here as well. All right, so this is the top of the temporary wall. And so this is the rim joist. This is what we ended up taking out, and you'll see that as we go through here. Yeah, again, just right water. Take it out with your hands. We end up taking out most of it with our hands. Again, this is a particularly bad case. If your siding is cupping, don't think that this is what your deck looks like necessarily, but it is definitely one of the possible outcomes. So this is the, yeah, let me see, I think there's a better, ooh, that was bad. All right, so this is the new structure going in. So this is what I was talking about. This is actually a floor joist that supports the floor going into the house like that. So 16 centers, right? And then this is the sill plate that sits on the foundation wall. Now, this is partially what, you know, every joist is nailed on the rim board, helps tie it together, right? So this actually got pretty rotted. But that's what happens. This rot creeps, right? So like right here it rots, and then slowly works its way back eventually. What we did in this case, instead of having to replace all the floor joists, which would have been a really Herculean effort, we sistered. You know, we put a sister joist in here, nailed about 3 feet back, and then bridged it on either side. Through bolted it. I mean, that thing's stronger than it's ever been. But so this is what you're looking at here. This is actually the deck boards, so the deck structure that is sitting away from the house. We had to do all this work. This gap is, you know, only a couple inches wide, so like we had to do all that work in there. Yeah, so this is the new rim joist, right? Doors completely removed. You can see how we built everything back together here. New insulation, new wall. Okay, beautiful, beautiful. This is ice and water shield, right? So I pointed out the aluminum flashing before. We put, actually this is a 3-foot wide tar paper essentially. It's self-adhering, and what it does is, so this is about 2 feet up and 1 foot down below the deck. So it's same principle, just, you know, more, right? So the snow would have to accumulate up to 2 feet before it really had a problem, before it could touch any of the sheathing. Before it could touch any of the sheathing. And so then what you're actually looking at here is we reattached, this is the new ledger board, pressure treated 2x12, right? New joist hangers for everything. And what this is an aluminum bend, right? So this is a piece of aluminum. We bend it like this. Let me see if I can do it here. We bend it like this, right? And we stick it on top of the ledger board. So now not only any snow would need to gather 2 feet, and anything above it, above the aluminum, would go back down behind the ledger board, but anything in this original 6 to 8 inch gap world is actually going to get pushed out this way and then drop behind the decking, right? Just behind the ledger board. Again, it's just an added level of protection. And all right, this is another thing I want to point out is this is, let me see, I think, yeah, so this is a James Hardy installation requirement. For this exact reason, James Hardy requires that between any horizontal surface and the James Hardy fiber cement board, there needs to be I believe it's a 2-inch gap at roofs. Maybe it's a 4-inch gap at decks, but I think this is 6 inches, and it has a built-in bevel there for the next piece of siding to sit on. But this is the exact reason. There is no product that we use in construction that's meant to be submerged in water for extended periods of time. Fiber cement board is great. It will last on your house with the proper upkeep for a very, very long time, but it is not immune to water. So this is a requirement that James Hardy puts in all their installation manuals. It's also for on top of roofs, right? So here, the next piece of siding that we put here needs to be installed 2 inches above that roof line. Any snow that gathers there, again, same principle, same exact principle. Nothing sits in water. Right, so you see that we extended that here, right? And then down the stairs that are right there. So I want to reshoot the end of this. That's the entire slideshow, but I really wanted to talk about what rot means, and like from a contractor's perspective and from a homeowner's perspective. I mean, unfortunately, like these things happen all the time, and it puts both the contractor in a bad light. Honestly, it makes me feel like I'm grabbing money, like I'm just doing a money grab, and I'm sure the homeowners puts them in a bad situation because they need to make a choice whether or not to repair the damage really, or save some money, and that's where you end up with you know band-aids and instead of bandages and lipsticks on pigs and that kind of stuff. um, what I just showed you, we ended up charging the homeowner additional $9,500. So it's not something that's cheap to fix. But I mean, really, there was no way not to do it. You're talking about the structure of the house, and potentially even greater damage if the deck pulled away, or and it seems like those are inflated scenarios, right? But obviously they're very extreme um, on all sides. But it's not something that I don't think any legitimate contractor likes to do. Is you know go into the pockets of a client for that much of additional cost. It's definitely something that homeowners don't appreciate either. Um, you know, the the thing about this particular fix was the difficulty. I mean, like, to say it was surgical was is probably not especially appropriate, but it's definitely not something that any guy could do. You're not going to send any guy over there and just throw in a new beam while the deck is hanging on the side, hanging off the side of the house. Point is that was, again, I think I said it a few times during the video, but that was a particularly bad example of what could go wrong. Um, how to mitigate it? Unfortunately, there's not too much you're going to do to mitigate it from a cost perspective. What you can do, which I would highly recommend, regardless of how good or bad you think your potential rot situation is if you're going to have renovation done, point it out early to a contractor. Point it out very early. Make sure that they understand that there might be a potential cost, and then regardless, either through hold money as a contingency, either through your contractor or outside of your contractor. Um, I mean, a good contingency is 5 to 8% of the total budget, um, which would have more than covered um, this particular scenario. But pointed out early, a good contractor will maybe do a probe to see exactly what they think they're getting themselves into, and go up in the attic, go into crawl space, do whatever they got to do to kind of go see what they could see before they rip the side of your house off, to try to get an understanding. We carried a minimal rock contingency in the contract. I think it was like 3 boards of plywood they pointed out, that the one specific area, but we had no way of knowing that we were gonna have to be replacing structure. Yeah, that's just some final points that I want to leave you with. Uh, I appreciate if you made this far. I'm gonna try to put a few more of these together the next couple of days. I have some time. So hope to see you again. Take care.